Hello, everyone. I think that we can start. Still, I will say a couple of words and probably our audience will be full. I am Lina Dagilienė. I will be a discussant of today's IN4ACT seminar. And it's a very great pleasure for me to open this seminar. It becomes a tradition because this is a 5th seminar. Entitled Rethinking Sustainability in the Circular Economy, Challenging Socioeconomic Models in Industry 4.0. And our presenter is Manuel Morales. So let me say a couple of words to introduce our presenter. Manuel holds a PhD in economics from the University Clermont-Auvergne and a postdoc at the Industrial Bioeconomy Chair in IN4ACT Business School, France. Currently, Manuel is a team member of ERA Chair and currently works at the School of Economics and Business. And indeed, Manuel has a diverse experience in research, consulting, lecturing, and today he will be sharing his expertise about environmental economics, industrial ecology, and sustainability. Very important issues today. So hopefully you will have a good time, and after the presentation, we'll have a great discussion. So you are welcome to write your questions in the chat or just to ask verbally. So I think, Manuel, the floor is yours, and good luck.
Thank you, Lina. Thank you everybody for being here, for have taken the time to get connected into this webinar. And also, I'm also really happy to be part of this series of webinars in the KTU and the IN4ACT group. So let's start talking about this really interesting issue. And that have many implications in the political and socio-ecological agenda nowadays. So let's start by saying that I don't want to give a breakthrough lecture about this topic. I know that many of you have heard about what circular economy means. My intention is rather to attract some academic interest over a specific systemic approach, way to approach circular economy. So I will present a systemic methodology able to fill some gaps when addressing macro scale issues in the circular economy, and also. I want to analyze how sustainability, talking about the net sustainability, could be influenced and also could influence circular economy. So I'm going to talk also about some limitations, the scopes of circular economy, and how those strengths and weaknesses can be set it up into a bigger frame of guidelines in Europe regarding circular economy. So saying that, it's also important to highlight the importance, because I'm part of the IN4ACT chair. It's also important to highlight the role of the Industry 4.0 in this specific methodology, because it will provide the means and the tools that can facilitate the access to those transition possibilities. Okay, so let's start by an overview of what we are going to see, what I'm going to talk about in this webinar, starting from the bullet points. and the anchor concept of circular economy and also sustainability that have a diverse, ambiguous understanding of what those concepts are. Then I intend to mention the circularity limitations, the circular economy limitations that have been identified during my studies in an exhaustive research in the available literature review. Then I followed the current challenges in circular economy, and also the methodological gaps that exist in the transition beyond to go beyond these micro scale indicators, because the purpose at the end is trying to bridge this gap, to go from micro scale indicators into a macro scale ones. So then I will present some discussion about the circular economy challenges and how to deploy that in a circular economy in a 5 steps methodology that is present here in the diagram, starting from the goal screening and finalizing by the proposing some leverage points and interventions that's going to be detailed during the presentation by itself. And finally, but not last but not least, I also want to present some conclusions about the applied methodology, and the most important, the explanation of the research projects that I'm engaging or that I'm working in, to detail the pool of expertise that can be put at the service of collaborative synergies with K2 staff, but also with other researchers or professors that were interested. Okay, let's start by the bullet points. And here and today I want to make two claims. The first one is that the circular economy may not deliver sustainability if circularity leads to increased material and energy consumption. So and the second claim is that we should consider this with great news, because the acknowledgement of that 100% of circularity is impossible means that now we can reinvent the new sustainable model that was hardly conceived without the means supplied by the Industry 4.0. What kind of means? I'm talking about artificial intelligence, digitalization, virtual reality, automation, of course. So in this figure that is in green and white here at my right, we can see that only 12% of material input was being recycled in the European Union in 2019, stressing the limited potential of recycling at the scale of the economy, at the whole economy. So, I mean, this could and should be improved, but recyclable materials remain really small portion of material throughput by itself. So we need to think not only about recycling, we need to expand our horizons, and that's what I'm going to talk about now. Okay, the two anchor concepts that need to be defined here, it's circular economy and sustainability in the next slide. First of all, there are slightly differences when talking about circular economy that, of course, can be discussed. But here is one of the, let's say, main definitions that are accepted by the academic, by the scholars, and it's that circular economy promotes the resource minimization and the adoption of cleaner technologies, while maintaining the value of production, materials, resources in the economy for as long as possible. What does it mean? It's really that it's not only the eco-efficiency that we are looking for, we are only looking for closing loops and for maintaining the materials in the economy as long as possible in order to reduce the final consumption, the final use of materials and energy that is coming into the economy. So regarding this, we identified which are the three R is reuse, reduction, and recycle. So those three principles are really related with the sustainable use of the circular economy. And the second concept that needs to be defined, and that it's provided by different axes, and one of these axes that let us define sustainability are the 17 Sustainable Development Goals that were settled by the United Nations in 2015, if I'm not wrong, which supply a set of indicators that facilitate the tracking of sustainability in a macro level. And they are not, of course, exempted of some criticisms expressed in the form of oversimplistic indicators and maybe some linear taken in a systemic way. But even though those represent a breakthrough, a breakthrough into the development of new indicators regarding the sustainability issues. There are two specific principles that we are going to highlight during this presentation. It's the principle number 7, the goal. So the goal number 7, that it concerns an affordable and clean energy, and the goal 12, that address a responsible production and consumption. And both goals are really linked and it is identified as the ones with the strongest ties with the circular economy, as we're going to see in the discussion section. Well, also another input that helps us to define sustainability paradigm is the strong sustainability. I'm here just to say that strong sustainability means that the different kinds of capitals are not substitutable. There's not substitutability in between natural capital and human capital, at least not perfect substitutability. So we need to take into account a threshold of the natural capital in order to maintain critical ecosystem within the planetary boundaries. So the central aim of strong sustainability is to protect and maintain this so-called natural capital, of course, which cannot be out below a certain threshold, because then we can create a risk a risk to the entire ecosystem in the plant, and the collapse of also of some ecosystem services if we don't take into account that. Okay. Okay, let's start with some circular economy limitations that are really relevant, because if we are not aware of the limitation of circular economy, then we have the risk to think in the dream of circularity, thinking that no matter how the economy is growing, then it's okay because we will turn that into a circular production process. But there are some limitations that needs to be taken into account when defining public policies and strategies to implement the circular economy. And the first one is what we call the biophysical limitations expressed as energy carriers, and it's as explained by the laws of the law of thermodynamics. Energy moves from high concentrations to more dispersed states that are unavailable for doing useful work. So physically, it's impossible to get 100% recycled. So, yeah, I mean, could be because of the energy waste when we are transforming those materials, but could be also because of some residual loss when we are transforming those. The second temporal system boundaries is the temporal system boundaries, and it's composed by two elements: the product's durability and the product's lifetime in the economy. The first time product durability has some evident strengths because it keeps functioning in the economy for longer, so it's good for economic circulation. However, there are some limitations also, because many of the impacts that new materials have in nature or in the human well-being are currently unknown. So in the long term could be a potential risk. Here we have the example of the asbestos, for example. So many materials related to asbestos were used in construction in the second half of the 20th century. And we recently realized that those materials were toxic and were the origin of some cancerogenic issues, illness. And then we have the limitation of the product's lifetime in the economy that should be considered when defining the sustainability threshold. For example, here we have the copper production graph. And for example, copper have an average lifetime of 40 years in the economy. So what seems to be as a really small increase of 2.5% is this up. Yeah. Is this blue line is the copper production with 2.5% of increase. But this slightly increase per year, when we are talking about exponential increases, ends in almost 3 times the initial value after 40 years of production, what counteracts at the end the positive effects of recycling. So what I'm saying here is that in order to respect the recycling potential, it's necessary to go below 100% of the per year increases, because if not, at the end, when we are recycling, for example, here in Cooper, 60% of the material, and at the end of 40 years, it's almost less than 1/3 of what we produce at the end, and it's not counteracting the cycle of waste at the end. So all that saying that it means that construction is not, we can think that construction wastes are not really relevant, but at the end, construction in the European Union and worldwide is one of the main streams, with more than 46% of the total streams. And also an important issue to stress here is that even when a smooth increase is required to be sustainable, the tools supplied by Industry 4.0 became the means for the dematerialization of products and also of services. We're talking here also about digitalization, smart alternatives. That it doesn't mean that because we are reducing or we are not having a huge amount of material increase of production, it doesn't mean that the products and the services needs to be reduced also. So here is when the Industry 4.0 could enter into the equation, providing some functional alternatives to the material reduction in the circular economy. Okay. The other 4 concepts that constitute the limits are the spatial systems boundaries. And nowadays it's kind of difficult to assess the global net sustainability, because it's really spread in different countries. For example, considering the situation in which mining a specific mineral like carbon, for example, is reduced, and then it's replaced for some biofuels like wood, for example, in the forest. Then it's difficult to have this comparability in order to take the allocation of the decisions. So the sustainability effects of these issues pose some complex questions when we need to make comparisons. And also the number 4 is the limit posed by the physical economic growth, the rebound effects that are really important or relevant, because we have identified that belonging to the main reasons why eco-efficiency is not in line always with reduction in consumption. Jevons, because it's also known as Jevons paradox. Jevons was a British economist who studied the relationship between the increase in the carbon mining extraction and the related increase in the consumption. So the more efficient it was the mining of carbon in Great Britain, the bigger it was the consumption of this material. So this is why it's known as the Jevons paradox. The 5th limit is the path dependencies lock-in, because even when we are economically, ecologically, and socially better. We propose better alternatives. The prevailing states of the actors that have the power at the moment resist to make some changes, and this is what is happening now, and that's also why many circular economic innovations have problems from penetrating the markets, because the current infrastructure that is designed for linear productive systems. And finally, number 6, the last limitation, it's regarding the concept of waste that has a long infrastructure, a long cultural and social influence. So here, yeah, just to say that it's the concept of waste is always changing and it's always dynamic. So what is now considered as a waste, maybe in the near future it's not going to be, or vice versa. Okay.
Manuel, if I also may, I meant to
Yes.
give some questions also, maybe because it was really very interesting to hear. But just like a summary, just my question would be, you know, taking into account all these limitations, yeah, of the circular economy, and we all know sustainability for a longer time, and the circular economy is quite a new concept. So do you believe that the circular economy is a new way, real way of implementing sustainability, or it's another buzzword because we have a lot of buzzwords, but indeed this is a way where we should go, let's say?
Yeah, well, really good and an interesting question, Lina. I think that sustainability contribution of circular economy projects is a question that needs to be taken case by case, because it's always different. But we can say that the integration of sustainability issues by itself is relevant in the circular economy. We need to think about sustainability when we are doing circular economy, because the evidence shows that it may be impossible to simultaneously fulfill all the circularity and sustainability requirements, depending on the context of each project. So of course, at the end, some critical choices have to be made. We need to prioritize some strategies, some decisions, but we can only do that if we apply some indicators or some assessment regarding sustainability into the circular economy. Thank you. I don't know if I answer your question. Thank you. Okay. Yeah, I mean, talking about the circular economy challenge by itself, society needs coherent tools and means capable to recognize and mitigate these negative interactions or trade-offs, and also to maximize the positive interactions to better address contemporary issues of the circular economy paradigm. Okay, let's go into the discussion part. So here, it's important to identify how sustainability in circular economy must be approached, at least from my expert or my particular point of view. We need to think about a systemic approach in order to better understand what sustainability could do to circular economy and vice versa. And here we claim that a comprehensive approach that it's integrating the micro, the meso, and the macro scales, it's necessary. If we intend to develop a macro scale framework like the one I'm trying to do here, we need to understand the coincidences and the differences regarding this structural behavior in the different regions. Yes? Is there a question? No.
It seems not.
So as we can see in this graph, there are some, I mean, what is as example of the micro level, we can see recycling rates, for example, waste reduction rates. And when we move into a bigger level of analysis regarding the macro, we analyze the interrelationships in between different actors, like, for example, in a industrial symbiosis, in a industrial network, how they interact. And this could be done also analyzing the flows, the net flows in between those different actors, about the optimization of those flows, and also the reduction. And then the third figure, the one about the four different steps, tell us how to move from this meso scale into the macro level of analysis that we're going to see here. Okay, the first step in order to get into this macro analysis of circular economy and sustainability is to define some goal. There are different goals, and here is when I'm talking that we need to allocate the resources that we have in order to realize what are the better strategies to achieve a better net sustainability results. So we have, according to the literature that we have available now, there are 3 different goals that are related to circular economy, and at least five different goals that are also related to circular economy, but they are more close to sustainability. And some of those goals could be complementary, but others represent some trade-offs in between the necessary resources that need to be invested to achieve those goals. So what are those goals? The first one in the circular economy is to close and to extend loops. Here is recycling, composting, cascading, all we can do in order to reuse or to close those loops in between a circle in the industry. The number 2 in the circular economy is to extend the product life. Let's say it's through eco-design, we can increase the lifetime of every product, almost technically every product. So this is also a strategic decision. And the third is to increase the underused capacity. Let's say it's the shared economy. So we put into a pool the different capacities, material, technical, infrastructure capacity that we have as society available, and then we bet for a better collective use of those resources. And regarding the sustainability goals, we can say the first one we can identify renewable in the energy mix, and also the increase of the energy efficiency rates. Those are also represented in the Sustainable Development Goals. The number 3 is the waste generation reduction. So we reduce our production of waste through eco-efficiency mainly. The number 4 is to get a greater diversity, which means higher resilience, changing some structural behaviors in the system. And the last, that is strongly linked with the strong sustainability, is to maintain critical natural capital, which means the ecosystem's function. We do everything we have at our hands to keep the vital functions that let our productive and consumption system to be alive. And the second step in this methodology is, once we have identified the different goals that coexist and that are interrelated in most cases, we made a stock and flow systems modeling. In this case, I'm presenting an example, a case study that I did in the biorefinery in France, the Pomato-Bassancourt biorefinery. That is one of the biggest biorefineries in Europe, and the biggest in France. And here we can see how to represent the system's complexity in the long term, using system dynamics as a modeling method. So we can see those arrows are the causal links between actors and their dynamic behaviors. So this way we can attempt a better understanding of the resource allocation, because we are not only thinking about of the flux, but we can incorporate some strategical decisions. For example, here we can incorporate the sugar production allocation, because of the price of one input, or the price in the market of the final outcome. We can vary the sugar production, or in the other hand, we can increase, for example, the biofuels. So all this platform is interlinked, and we developed this model with the data gathered from 10 years, from 2007 to 2016, and then we run different scenarios according with the potential variability that could exist in this platform. And here we are not talking just about one or two firms. We're talking about more than 5 big entities that are interrelated, because they are using products and products that are produced in the same biorefinery. So some of the products that were engaged were for example, the CO2, the green syrup, the stillage that was used as fertilizer at the end, and also we can identify some of the recommendations that are possible to provide once that we understand the dynamic that is behind this kind of systems model. Okay. Okay, so here we have the stocks and flows system modeling. That's the second part of the creation of this system dynamic modeling. And it's important to know that once that we acknowledge the available stock and flow, that let us know the production capacity of the entire system, it's important to know the synergies and the impact that the production decisions could emerge into this transition, because systems dynamics at the end, it's a method that aims to analyze fluctuations around these systems in general. So as we can see in the two graphs, we developed three different scenarios. Here we can see scenario number 1, number 2, and number 3, and the different behaviors regarding the fluctuations of different variables. What are those variables? For example, the application of biofertilizers in the land that provides the input for the biorefinery, but also the rate of technological development of the sugar beet productive landfills, and also the variance of the agricultural land that is designed for beet production. And I'd say also, I mean, all this is important because we are not, as I already said, we are not just talking about stock and flows. All that could be translated into economic and strategic decisions, because the amount of production that it's destined to the production of biofuels, for example, it's also inputs that are taken from sugar production. So we cannot produce biofuels without impacting the sugar production. So once we know that, and once we know the price in the market of those products, then we can take better decisions about what strategic choice we need to do as businessmen, as practitioners, or as public authority in a territory. Okay, then we jump into the third step of the methodology. This is the case study across the impact analysis. And we can see here, as I already told you, that some of those goals could create trade-offs. And here we see that it's a bit moved, but the renewable energy and the diversity and ecosystems functioning are according to the score. It's in -1, which means that it's constraining. It means that when we produce more renewable energy, translated into biofuels, it impacts the ecosystem, reducing the diversity. Why? Because when we produce more biofuels, we reduce the quantity of byproducts that have been used by other firms, and also by other and this will reduce the resilience at the end of these ecosystems. Okay, the fourth step is also the creation of some micro level graphs where we can see how different it's a causal loop here, and in this map we can identify the interconnected variables through these arrows, and those arrows represent causal relationships with a sign minus or plus, which means that the plus means that it's a reinforcing loop. The minus means that it's a balancing loop. So this could help in order to provide some public recommendations and to better visualize the feedback processes into a micro level. To create, just to add that to create this this graph, we not only take into account the outcome of the biorefinery diagram, we also take one other case study that is the Dunkirk industrial symbiosis case, which we also take some conclusions from it. We're almost finishing here. Just to say that it's also important to propose once we have this macro approach that gave us some insights about the behavior and the feedbacks that take place into the economic and the environmental system. It's important because we can get some relevant recommendations, some drivers that could change the structural functioning of the system, of regional systems. For example, in the French case, we identify two different clusters, one for the biorefinery cluster and the biorefinery case, sorry, and the second cluster is for the Dunkirk, the port system dynamic case, that it's with construction and energy production by heat. So the first cluster is a coherent with coherent goals emerged from this French circular economy, demonstrating the potential of synergies between three levels. That is the closing of the loops, the extension of the product lives. It means the innovation, which means also the possibility to get some renewable energy. This is in Dunkirk, and also the reduction of the waste that it's produced in this case in this case. And the second cluster that is also hardly linked with the first, because there are some trade-offs that could be that have been identified. The second cluster is more linked with the biorefinery, and this has the potential to link the bio-based diversity in the biorefinery. Means that the more we close the loops, the more we generate resilience in the system, even if we are not encouraging the production of biofuels. It means that we need to take care when we invest in this kind of substitutive of this substitution in the innovation, because it's impacting in the resilience of the ecosystem by itself. Okay. As conclusion, the contradictions between sustainability and circular economy restrain most of the circular indicators in the micro scale. So it's hard to cross these limits and go to the macro scale analysis. And this also avoid the discussion on new socioeconomic models like Industry 4.0, and the means and tools that it provides to the overall discussion. And the last conclusion is that when we engage this kind of participatory and stakeholders, and we encourage stakeholders' participation, this increase the ownership of the industry the ownership of the methodology by itself. So practitioners, companies, firms, political institutions are more linked with the outcomes that we obtain out of those projects. And finally, I think that it's also one of the main intentions of these webinars is to invite people that are interested in this kind of research, but that share some research interest. Because, for example, I am part of a work group that looks to create a consortium to answer a Green Deal call, not this year but for the next year. The call is the demonstration of systemic solutions for territorial deployment of circular economy. I mean, this is one of the potential methodologies that could be engaged in those kind of efforts. But there are many institutions that are also interested and that we are working with to do this kind of research. And of course, part of my research is to go into a more European level. I have already some case studies in Western Europe, means France. I also have some in Sweden that I have made, this system dynamics modeling in the stock and flows. But I'm missing some studies from Eastern Europe and from South Europe. So I have been thinking in Lithuania, and I heard yesterday that they have some efforts to engage Continental, the company, and it could be also a really interesting case study that could make nice contributions for this. Thank you so much.
Thank you very much, Manuel. That was really a very interesting and I should say quite deep issue yet on conceptual aspects between the sustainability and the circular, and also modeling and the results of more concrete cases that like connection of micro and meso levels. And of course, it is also very important, this last, let's say, slide, because it's not just the presentation of some research topic, but it's also an invitation, let's say, for, let's say, some opportunities to collaborate and to have synergies in let's say, common research topics. Yeah, but also to continue the research topic, we also have several questions. And I would like to read it. The first one, Ritis raised the question, is there an existing empirical evidence about the net effect measurement for circular economy initiatives that could be clearly assigned as the effect created through circularity or sustainability measures implemented? What factors are the major ones in such measurement?
Can you repeat it, because I didn't get it.
Yeah, maybe you also can see in the chat, because it's mainly about the empirical evidence about the effects of the circular economy. What are real tangible effects, let's say? Is it possible to measure them?
If I can add, that would sound probably more properly. My question is related with net economic effect, as the sustainability or circularity is creating positive and negative side effects for existing systems. Okay, so maybe you have made some studies with empirical evidence about net economic. So this means that positive higher than negative effect on the sustainability or circularity measures implementation. Thank you, and sorry for interruption.
Yes, of course. I mean, there's an increasing, let's say, an increasing literature that is being published about the assessment of the net sustainability, and here we have also a condition in between the absolute and the relative benefits, for example, because we can say that we have had, for example, some decoupling in between the environmental negative impacts and the positive increase in the economy, but most of the studies show a relative increase or a relative decoupling in between the sustainability of some cases. So we have in a planetary level, we have still to provide or to make more integrated or macro scale analysis in order to get a net outcome about sustainability, because most of the studies that have been made, it's in a micro level for specific cases or in a specific cities or territories, but doesn't get into a bigger scale level of analysis.
So Rytis, are you happy with the answer?
I understood the answer. Basically, I'm not happy with the answer, but it's not the problem of presenters. It just shows that the topic is very new, and some broader understanding and broad measurement, I would say, well, factors, maybe some instruments are needed. So, and there's opportunities for researchers to present those measures. So
let's just add a couple of things, because I think instruments are starting to get available, because many efforts at least at the European level have started to take form, providing more statistics about circular economy, about recycling rates, about the CO2 emissions, but are more those are comparable, let's say. So once we have the possibility to get data from these different territories and data that it's comparable, then we can make this this modelization of a bigger scale. But we need to at the beginning we need to understand the behavior, the structural behavior that it's functioning in every system that we are analyzing, because it's hard to make just a static analysis assessment of a specific case or a specific city or country. We need to understand how it's moving in the long term, or what are the drivers that are influencing this behavior.
And also, if I may add, I think that indeed, when we're talking about macro level, of course, that is problem with, let's say, data, and that indeed this system is very complex. But of course, there is already a start of let's say, if we talk from more economic point of view, let's say DSG models like dynamic stochastic general equilibrium models are started to be created in order to evaluate the effects of going to more circular to the whole economy. So, but that's true. It's just a blue ocean, let's say, for the further research. And also we have a question from Takis. What are the main sources of opposition to a transition to a circular economy? The main source of opposition.
Yeah. I mean, as I already said, there are many or quite few limitations. And I can, if you ask me to pick one, I think that currently nowadays the path dependencies are one of the forces that are hindering the transition into a circular, more circular economy, because the current production system, it's basically linear, and we need to replace the existing infrastructure that we already have working in most of the productive systems or networks into a more circular option or alternatives. But this in fact, it's really linked with what I said before, that we need to take the tools and the means that we have available from for example, Industry 4, in order to make digitalization, in order to make artificial intelligence and smart production work in our favor when we are thinking about the creation of circular economy alternatives that can replace the existing linear one.
Dear Takis, you are also with us, so is it okay with the answer? Would you like?
Yeah, thank you, Manuel. That's exactly what I was getting at. The other issue is, let's say we're talking about alternative energy. We have huge vested interests. Yes, you call them path dependencies, but there is a political economy behind these. And it is very difficult for me to think on how to create coalitions of interests, be they industrial, social, policy, whatever, and environmental and so on, that would support this transition. So I'm thinking more of an operational level on how do we put together a collectivity which is sustainable in both industrial, environmental, this symbiosis thing, right? So I was thinking more of the political economy map. We all know who is opposing what, right? We know that there are vested interests. People still want to drill, right? Alaska and so on. In Europe, we have different dependencies. Germany is nuclear, is gas. France is nuclear, right? So that's why we don't have a common energy sort of framework in Europe. And I was thinking what would be a common ground on which to address some of this, but I fully take your point about path dependencies and how difficult it is to get them out, to get out of this predicament. And Industry 4 could make a very interesting contribution, as you said, about different automation systems which sort of take the weight away from previous dependencies. But it needs to be, I think we are at the beginning, as Riti said, we are probably at the beginning of a very promising area. And it's obviously not mature enough to have very heavy indicators and very complicated indicators and so on. But yeah, thank you for the answer and thank you for the presentation.
Yeah, just maybe as a final remark, I don't know, just adding to the comment of Takis, that I think that, of course, synergies in between different frameworks, it's really necessary. Because, for example, when we talk about the reduction of the reduction of the growth in production to a level of not more than 1%, then it's really complicated to get people engaged. But when we change this and we say, okay, it's a material reduction, but it doesn't mean that this could be this doesn't mean that it will be translated into a reduction in products and services or a reduction in income, because we have some means or some tools like the digitalization, the servicification, or the sharing economy for many products that can be complemented with those kind of a strategy. And then we change into a narrative, not to a reduction of the production in itself, but just into a shift into an alternative proposal of more digital, more non-material set of alternatives.
Thank you very much. We already, start an interesting discussion, and probably the interesting questions and the answers shows that how much we can dig deeper here. But actually, we are, out of time. So again, probably thank you very much for all, and I think that. Relating to the last slide of Manuel about possible collaboration, looking forward to see what can happen in the future regarding this topic in diverse areas. Yeah, because today we heard more about France case, but of course it is also would be very interesting to know more about Lithuania. Yes, because we are all in the same European Union for the same circular economy strategy. So thank you one more time for Manuel, a great presentation, and for everybody who shared her time here to be, and looking forward for future cooperation.